Hello friends, welcome back to my channel Engineering Mathematics DJ Ganit. In this lecture we are going to discuss one question on Poisson distribution which was asked in GTU Summer 2020 exam. So let's try to solve this problem. At a checkout counter, customers arrive at an average of 1.5 per minute. Find the probabilities that at most 4 customers will arrive in any given minute, and second part is 1 customer will arrive in the first 1 minute and 2 customers will arrive in the next 1 minute. So first we define what is random variable in this case. So we can observe that here they are talking about arrival of customers on some checkout counter. So we can define our random variable as capital X equal to number of customers arriving at a checkout counter. So first we define what is capital X. For this problem we consider capital X equal to the number of customers arriving at a checkout counter in any given minute. Here time interval is minute. So they have given arrival of customers in time interval of minute. Okay, it is given that at a checkout counter customers arrive at an average of 1.5 per minute. That means average number of customers arriving at a checkout counter in any given minute is 1.5. Given that average number of customers at a checkout counter in a given minute is 1.5. So if capital X is the number of customers arriving at a counter in any given minute, then this 1.5 is nothing but mean of this random variable. Okay, so therefore the mean of capital X is 1.5. And we know that if we are talking about the count of events in a given interval of time, then that random variable follows a Poisson distribution. So for Poisson distribution we require average number of events occurring in a given time interval. So here average number of customers are 1.5 in a given time interval of 1 minute. That means here lambda is 1.5. So X is a Poisson random variable with lambda equal to 1.5. X is a Poisson random variable with mean lambda equal to 1.5. So therefore we can write the probability mass function of capital X is we have to remember this formula for PMF of Poisson random variable. It is e raised to minus lambda raised to x divided by x factorial. X can take values starting from 0, and here lambda is 1.5, so we put lambda equal to 1.5. So e raised to minus 1.5 to the power x divided by x factorial, x equal to 0, 1, 2. So this is the probability that there will be x customers arriving in a given minute at a checkout counter. This is the probability of x customers arriving at a checkout counter in any given minute. Now we try to find out required probabilities. In first part we are asked to find the probability that at most 4 customers will arrive in any given minute. At most 4 means maximum customers are 4 and minimum customers are starting from 0. Okay, so probability that at most 4 customers will arrive in any given minute. Okay, we can shortly write minute in this way. Okay, let me write this bracket because I have written here this bracket. So this is represented by, this event can be represented as capital X is less than or equal to 4. Now this means we have to add probabilities starting from 0 up to 4. So probability that x equal to 0 plus probability that x equal to 1 plus x equal to 2 plus probability that x equal to 3 and plus probability that x equal to 4. So we can use this formula to find out all these probabilities. We put x equal to 0, 1, 2, 3 and 4 respectively, and we can observe that there will be e to the power minus 1.5 common in each term. Okay, so first we write down probability corresponding to small x equal to 0. So for that we put x equal to 0. So 1.5 raised to x, that is 0 here, divided by 0 factorial. Then we put x equal to 1, so e raised to minus 1.5 is there, 1.5 raised to x, that is 1, divided by 1 factorial. Then we put x equal to 2, so we have e raised to minus 1.5, 1.5 square divided by 2 factorial. Okay, we are using this formula for different values of x starting from 0. Then we put x equal to 3 and x equal to 4, so this is e raised to minus 1.5, 1.5 to the power 3 divided by 3 factorial, and last value is for small x equal to 4, we have 1.5 raised to 4 divided by 4 factorial. Now in each term we have e raised to minus 1.5 common, so that we can take outside. Now 1.5 raised to 0 is 1, 0 factorial is also 1, so there will be 1 left here. Similarly here we have 1.5 raised to 1 divided by 1, that is 1.5 plus 1.5 square divided by 2 factorial, and 2 factorial is 2. Similarly in this term we have 1.5 raised to 3 divided by 3 factorial, that is 6, and in this last term we have 1.5 raised to 4 divided by 24. So we can use scientific calculator for all these calculations. Okay, this I have calculated using my scientific calculator. This I have written as 1 plus 1.5, that is 2.5, plus 1.5 square divided by 2. So you can check with your calculator. I have calculated all these values using my scientific calculator that I am writing here. So this is for 1.5 square by 2, then this is nothing but 0.5625, and this is nothing but 0.2109. So if you add all these values and if you multiply with e raised to minus 1.5, your answer will be 0.9814 up to 4 decimal places. So this is the probability of at most 4 customers arriving in any given minute. Now if you are having cumulative Poisson probability table, then you can use that table to find out this probability. So we can do the same process using Poisson probability table. So I think table will save our time of calculations. So we are interested in this probability that capital X is less than or equal to 4, and we have mean of given Poisson random variable is 1.5, and we are interested in this type of probabilities from Poisson table. So Poisson table is for cumulative probabilities. So if we compare with this, we have small x equal to 4. So in cumulative Poisson probability table, we will look for lambda equal to 1.5 and x equal to 4. Okay, so we try to find out this probability directly from cumulative Poisson probability table. So this is the cumulative Poisson probability table. Here instead of alpha they are using instead of lambda they have used alpha, but this is our lambda, that is mean of Poisson distribution, and here in under this x we have corresponding x values, and these probabilities are cumulative probabilities. That means they are the probabilities of this type, capital X is less than or equal to x. Now in our case we are interested in this probability for lambda equal to 1.5. So first we find out lambda. So lambda equal to 1.5 corresponds to this column, and value of x is 4 in this case. So we search for 4 under x. Okay, so this is corresponding to x equal to 4. So we consider the intersection of row corresponding to x equal to 4 and column corresponding to lambda equal to 1.5. So if we take intersection of these two, this row corresponding to x equal to 4 and this column corresponding to lambda equal to 1.5. So if we take intersection of these two, we have this value corresponding to x equal to 4 and lambda equal to 1.5. So we can see we have 0.9814. So this probability using cumulative Poisson table is 0.9814. Okay, so using cumulative Poisson probability table we are able to write down this value directly. Okay, so this is we can write in the bracket that using Poisson probability table, or we can write cumulative Poisson probability table with lambda equal to 1.5 and x equal to 4, and we can compare both the answers are same up to 4 decimal places. So you can compare if you are going with this formula, and if you are using calculator you will require more time as compared to this method, that is using cumulative Poisson probability table. So if you are having probability tables with you, it is better to use probability table instead of going for calculations. Now we move towards the second part of our question. So in second part, let me check what is asked. So in second part we have to find the probability that one customer will arrive in the first 1 minute and two customers will arrive in the next 1 minute. So this second part is probability of two events. One event is one customer will arrive in the first 1 minute, and second event is two customers will arrive in the next 1 minute. Okay, so for second part, first we define or we denote these two events by E and F. Let capital E denote the event that one customer will arrive, one customer will arrive in first 1 minute. In first 1 minute. So we are considering this required probability as probability of first we consider one customer will arrive in the first 1 minute, as this event we denote by capital E, and second event is two customers will arrive in the next 1 minute, that we denote by capital F. So we consider capital F denotes the event that two customers will arrive in the next 1 minute. So this event corresponds to capital X equal to 1, number of customers are 1, and this event corresponds to capital X equal to 2. Now it is clear that both the events are independent events because arrival of customer does not depend on the arrival of remaining customers. So this E and F are independent events. Clearly events E and F are independent, or they are independent events. Now required probability is nothing but probability that one customer will arrive in 1 minute, that is event E, and two customers will arrive in the next 1 minute. So the event in part 2 is nothing but event that E and F. Okay, so we can consider this part 2 as event E and F, that means E intersection F. So required event in part 2 is nothing but E intersection F. So we can write in this way that probability that one customer will arrive in first 1 minute and two customers will arrive in next 1 minute. This is nothing but probability of E intersection F. Now E and F are independent events, so we know that using multiplication rule this is equal to probability of E times probability of F, because E and F are independent events. E and F are independent events. Now event E corresponds to capital X equal to 1. Event E is the arrival of one customer in 1 minute. So event E is equivalent to capital X equal to 1, and event F is arrival of two customers in a minute. So event F corresponds to capital X equal to 2, and these two we can calculate using our probability mass function. So our probability mass function is e raised to minus 1.5 raised to x over x factorial. So first we consider x equal to 1 and then x equal to 2. So that we calculate here e raised to minus 1.5 raised to 1 divided by 1 factorial into, now we put small x equal to 2, so 1.5 raised to x, that is 2 divided by 2 factorial. Okay, so if you calculate first one, you will have 0.3347 using scientific calculator. I have done this, and this is second portion is 0.2510, and if you multiply these two, required probability is 0.0840. Okay, so this is the probability. 0.084 is the probability that one customer will arrive in first 1 minute and two customers will arrive in next 1 minute. Okay, so this part 2 you have to be careful. In part 2 you are asked to find out probability of intersection of two events. One event is one customer in first 1 minute, second event is two customers in the next 1 minute, and required probability becomes intersection of these two events E and F, and because these two are independent, we have this formula: probability of E intersection F equal to probability of E into probability of f, and this is equivalent to capital X equal to 1, this is equivalent to capital X equal to 2, and using the probability mass function we are able to decide this probability. Okay, so in this way we can easily solve this type of problems, provided that we must be able to decide that given problem is corresponding to which distribution. So whenever we have count of events in interval of time, then that distribution is of Poisson distribution. So for Poisson distribution we will be given occurrence of events in an interval of time, and we will be given average number of events in a given interval of time. Okay, so this is all about this session. I hope you like it. Thank you very much.